Hello, welcome to my VisionOS documentation series. We'll be going over all the documentation available by Apple, and let's see how much we can learn from Apple and how much of a VisionOS developer we can be by going through all these articles. Okay, quickly now, let's look at the overview. In this overview, we learned that the scene is extremely important here. We use the scene to display both 2D and 3D content. Here we have two examples, one of a scene with a window and a scene with 3D objects. We want to learn and familiarize ourselves with these scenes so that we can build bigger projects. Let's learn how to make these scenes and build content around them. Let's start by creating your Xcode project. Okay, to create a new project, create new project in your Xcode beta. You want this because you can then create a VisionOS app. Let's select that. And we're going to, let's say this is a first VisionOS app. Give it some name. We're gonna start with a window here. We're not gonna do any immersive rendering. Let's see what they want us to do. It's a little different already. So we're just gonna select none and let's begin. Let's just put this into this Xcode projects. And here we have our first content view. All right, so what they want us to do next is to modify the existing window and build your initial interface using the standard SwiftUI views. Here we're going to do the very basics by introducing a background of black opacity 0.8 to modify our view. Let's see how that changes things. Let's go to app. Let's give this a background of .black, .opacity 0.8. Okay, let's run that app. Okay, we have introduced a square background into our content view. Exciting. So to learn more, we will want to do SwiftUI Essentials, which you can find in my video series, and you can click the link here to learn some more about how to work with SwiftUI. All right, so quickly, looks like we go straight into handle events in your view. Many SwiftUI views handle interactions automatically. All you have to do is provide code to run your interactions and they occur. Add SwiftUI gestures, handling taps, long press, drag, rotations, and zoom gestures. The Swift system automatically maps the following types of inputs to your SwiftUI event handling code. Okay. Indirect input. The person's eyes indicate what they want to touch, and touching your uh, thumb and forefinger together is a selection. Here we have direct inputs. By clicking a virtual keyboard, we'll get characters, and we have physical keyboards and touchpads and other things. Here we have more information about handling user inputs. Okay, finally the meat of it. Let's build and run your app and see how it looks. Similar has a virtual background as a backdrop, and we'll use our mouse and keyboard to navigate around, tap the window bar, move around, see what's going on, resize. Okay, so with that, we have come to a close for this portion. So just close, open. Looks like the window's not resizing properly. What we have learned here in this create your first VisionOS app is that we have created our first VisionOS app. We just haven't done very much with it except for changing the background color. What we want to do is take the next step and add 3D content to our app. Okay, let's see what the Apple documentation has to teach us in adding 3D content to your application. As we know, VisionOS is a spatial computing device where we have the third dimension of space, and we want to be able to use that. So we will have to work with 3D objects to make that happen. Here we have three types of space: window, volume, and immersive space. And here we're gonna go do a quick overview about adding depth to a traditional 2D window. Looks like we don't have access to this code that will generate this particular satellite and object at this point in time. However, it will tell us that we can customize our views and use 3D layout options to arrange our views inside the window with shadows, visual effects, hover effects that highlight the object when someone looks at it. We'll lay out using Z-stacks, put it up in front of the window. We have transform 3D effects to animate view changes and rotate the view using a rotation 3D effect modifier. I think this is to just give you a quick sense of all the tools that you can possibly use to animate and make your 3D object stand out in your 2D scene. So you can add static 3D models to your 2D window. Using the Model 3D view, you can load USDZ files and other types into your window. Use this in place where you already have model data in your app. Download it from your network. For example, a shopping app might use this type of view to display 3D versions of a product. Okay, a quick overview here, not much code. Let's take a look at display dynamic 3D scenes using RealityKit. RealityKit is Apple's technology for building 3D models and scenes that you update dynamically on screen. In VisionOS, use RealityKit and SwiftUI together to seamlessly couple your app's 2D and 3D content, load existing USDZ assets, or create scenes in Reality Composer Pro that incorporate animation, physics, lights, sound, and custom behaviors for your content. To use a Reality Composer Pro project in your app, add the Swift package to Xcode project and import its modules into your Swift files. For more information, manage files and folders in your Xcode project. Here we see that this is the Happy Beam app, and we haven't gone there yet. This is a quick overview. So when you're ready to display 3D content in your interface, use a reality view. This SwiftUI view serves as a container for your RealityKit content and lets you update the content using familiar SwiftUI techniques. Okay. The following example shows a view that uses reality view to display a 3D sphere. The code in the view closure creates a RealityKit entity for the sphere, applies a texture to the surface of the sphere, and adds the sphere to the view content. Okay, I think this is something that we can do now. Let's put it into action. We're going to create a sphere view of type view. That, of course, following that protocol, we have our body, and we produce some view in that body. Of course, this view is going to be a reality view, and in this closure, as you can see, here's some content in, and we set the model to be a model entity and give it a mesh and a material of white and is metallic, a mesh of a sphere of some sort, and we'll add this to our content, and we should be able to display a white sphere. Let's put that into action. All right, this is exciting because we're going to first make our first file. So we're going to go here into our first VisionOS app, create a new file. We're going to call this sphere view. Once we create this file, we have our struct sphere view and our body of some view that follows this view protocol. Currently, we have a text hello world. This is a sort of view, and the sort of view we actually want is a reality view. So we need to import reality view and RealityKit and import RealityKit content to pull in that particular type of view. So let's take a look at that. Before we pull these libraries in, let's see if we can try to make a reality view. Oh, looks like we can. never mind. I am wrong. Let's put that in. Oh, never mind. RealityKit UI is not imported. So if you import this, then we will fail to build. So now that we have RealityKit, we can do this. So this is, I believe, it takes an enclosure of content in, and now we can add things to our contents. The thing that we want to add is a RealityKit item called Sphere. Let's say, I believe, give me a moment. Let's pull this from Google Chrome. They call it a model, but we know it's a sphere. So let's just call it model and follow the rules. So model equals model entity. This creates a RealityKit entity to add to a reality view, which is displayed by our body. So our model entity is going to be made up of a mesh and a material. The mesh is going to be we're going to generate I believe it was a sphere with a radius of 0.1. Looks like we can generate a bunch of different types of items. Now, a material that we have chosen is a simple white. Let's see, simple material in a array, and this simple material has a color of white, and it's true that it's a metallic. So those two things are true. Once this occurs, we can add this model to our content that is going to be displayed here in our reality view. So content.add our model. And now we have our sphere. It's not white. It's definitely not white. Uh, I don't know exactly why that is at this point, but it's definitely black. Okay, that is strange. But let's zoom into this sphere, and as you get closer, so it becomes transparent. And if you move to the side, and as you can see, it is 3D. It's a 3D object inside your 2D scene. Very, very cool. Okay, that's just me fooling around. All right, so that is how we create 3D objects according to this documentation. We can change this object because we saw a few different types of objects that we can make. We can do a sphere, a box. Let's try to change the color a little bit. Let's see what happens if we type in black. Okay, it's very dark now. It looks like it's the reflections off of the whiteness of it. Now it's just pure darkness, as you can see. Let's try blue for fun. Let's see what's going on. Ooh, that's so cool. Okay, and let's turn off the metallic. Let's give that a little test. And oh, that's very dull. Let's give it a white now. And now it's a little grayish type ball, but still not white. All right. Well, let's go back to our documentation here. Let's see what's next for us. Let's reset everything back to this original, and let's add the next piece of code, which is to update. It looks like what we want to do here is we're going to create a scaling. Scaling is false right now, but I believe what we want to do here is that we want to be able to change the size of the sphere when we touch it, which is in this next piece of code. So let's type this in and move forward, because that's how we interact with our RealityKit models through our reality view. Okay, let's do it. Here we have our content. Let's do our updates. And let's see what they want. They want to take in the content. And this is our model. if let model equals content entity dot first, if let model equals content dot entities dot first. So it looks like we're pulling from the first item. And if that is so, we're gonna set the model transform.scale and update equals that scale to a 3D from X, Y, and Z points of 1.2, or we're going to stick at 1.0 the whole way. So how do we read this code? Let's take a look at scale, and it looks like we're taking in a, right, we are missing the var scale equals false. So what we're doing here is we're taking in three objects, which is SMD3 float, which is an array of 3 float items. If we look deeper into the developer documentation, it's this SMD3D float, and it looks like there are no examples here yet, except for here are the instance properties, and it has a subscript, and that's why we're able to do X, Y, and Z. Okay, cool. Let's move on to the next step. But before we do that, let's do a little reading, make sure we know what this code does by the documentation. When SwiftUI displays your reality view, it executes your code once to create the entities and other content. Because creating entities is relatively expensive, the view runs your creation code only once. When you want to update the state of your entities, create the state of your view and use an update closure to apply those changes to your content. The following example uses an update closure to change the size of the sphere when the value in the scale property changes. Okay, that makes sense, but I believe this should be an add state, shouldn't it? Well, let's move on to respond to interactions with RealityKit content. All right, let's start by reading. To handle interactions with the entities of your RealityKit scene, attach a gesture recognizer to your reality view and add the targeted to any entity modifier to it. After, attach an input target component to the entity or one of its parent entity. Add a collision shape to the RealityKit entities that support interactions. The targeted to any entity modifier provides a bridge between the gesture recognizer and your RealityKit content. For example, to recognize when someone drags an entity, specify a drag gesture and add the modifier to it. When the specified gesture occurs on that entity, SwiftUI executes the provided closure. The following example adds a tap gesture recognizer to the sphere view from the previous example. The code also adds input target component and collision component to the shape to allow for the interaction to occur. If you omit these components, the view does not detect the interaction with your entity. All right, let's add these components to our model first. These particular models, components, will give us a input target component. So what that exactly does, according to the documentation, it allows us to interact with the shape. We'll look into what that does exactly once we type in this code, and I know for sure the collision component makes it available that we can collide with the object with this particular shape. It's like a mesh on top of a mesh. Let's go look into it. I think input target component allows for a collision component to be added, but we'll look into it some more. So here we go. Before we add this model, let's model.components.add. Is it .add? Set. And we're going to do it input target component. So this creates a new instance of an input target component with a set of allow input types that define the kind of inputs the component entity can receive. All right, so it gives it the ability to be touched on, receive system inputs. Okay, currently I believe this gives it all sorts of inputs. Dot components dot sets. This time we got it, and we're gonna do a what you call it. Let's see, collision components. Collision components, and we're gonna do a shape. The shape is going to be dot sphere, generate sphere probably, of radius of 0.1. So perfectly the same size, and that way we don't make it too big. Otherwise, clicking outside or click of the sphere would force a sort of collision and input to happen, which we don't want, and we don't want it to be too small, because if it's too small, what happens is that, well, we don't know where to click. The user does not know where to click before the action happens. Okay, so that enables the touching of the sphere. Let's update the sphere based on that touching. So as I said earlier, we're going to change the scale to be an at state so that we can update the scale. And we're going to transform that scale with a gesture, a tap gesture targeted to any intended entity on end. So any entity in this reality view content will based on the touch will toggle the scale state. Okay, so we're gonna do at state private var, and on updates we want to add a dot gesture. I believe this is after the update. Oh, that's interesting. It's after updates. So this basically throws this modifier onto the entirety of the reality view. So tap, was it tap gesture? Tap gesture. Gesture dot target to any entity that's available and on ended, and we have an action, and that's a closure, and on closure. So let's do a blank, and we'll do a scale dot toggle, and that should do it. So once we toggle, it got bigger and it grows smaller at this point. And let's set that metallic finish back to true to get that look that we wanted. All right, with that, we can now make interactions with our 3D object in our reality view. Time to move on to the next piece of documentation, which is to display 3D content in evolved value. All right, let's start by reading again. When you need more control over the placement of your app content, add that content to an immersive space. An immersive space offers an unbounded area for your content, and you control the size and placement of the content within the space. After receiving permission from the user, you can also use ARKit with an immersive space to integrate content into their surroundings. For example, you can use ARKit scene reconstruction to obtain a mesh of the furniture and nearby objects and have your content interact with that mesh. An immersive space is a scene type that you create alongside your app other scenes. The following example shows an app that contains an immersive space and a window. All right, so we add an immersive space into an app, and we call this ID solar system, and we provide a solar system view. We don't have any of that. So let's just read the code and keep going. If you don't add a style modifier to your immersive space declaration, the system creates that space using the mix style. This style displays your content together with the pass-through content that shows the person's surroundings. Other styles let you pass through to varying degrees using the immersion style selection and in modifier to specify which style your space supports. If you specify more than one style, you can toggle between the styles using the selection parameters of the modifier. Okay, here's a big warning. We should read it. Be mindful of how much content you include in immersive scenes that use the mix style. Content that fills a significant portion of the screen, even if that content is partially transparent, can prevent the person from seeing potential hazards in their surrounding. If you want to immerse the person in your content, configure your space with the full style. And for more information, create fully immersive experiences in your app. In essence, we want to either be 50% mix or just go full on, full style so that people don't run into things. Otherwise, you probably get complaints or something. I ran into my couch because of this damn app. All right, so remember to set the position of items you place in a immersive space, position SwiftUI views using modifiers, and position a RealityKit entity using its transform components. SwiftUI places the origin of a space at a person's feet initially, but can change this origin in response to other events. For example, the system might shift the origin to accommodate a share play activity that displays your content with spatial personas. If you need to position SwiftUI views and RealityKit entities relative to one another, perform any needed coordinate conversions using the method in the content parameters of RealityView. To display your immersive space scene, open it using the open immersive space action, which you obtain from the SwiftUI environment. This action runs asynchronously and uses the provided information to find and initialize your scene. The following example shows a button that opens the space with the solar system identifier. So earlier we have the immersive space scene. Now we have a button probably inside our window group content view where we have a button that says a label of show solar system. And what this does is that we will open the immersive space asynchronously using an await. With that, when an app presents an immersive space, the system hides the contents of other apps to prevent visual conflicts. The other apps remain hidden while your space is visible and returns when you dismiss it. If your app defines multiple spaces, you may dismiss the current visible space before displaying a different space. If you don't dismiss the visible space, the system issues a runtime warning when you're trying to open the other space. All right, with that, we have gone through everything we needed to know about adding a 3D content to your app, and we have gotten a little sense of creating a fully immersive experience at this point. So that brings us into the next piece of documentation, creating fully immersive experiences in your app. And I'm just going to split this into another part of the video. Thank you for watching. This is part 1 of learning everything we can possibly learn in the VisionOS documentation made by Apple. Thank you very much.